Okay, in this video I'd like to continue the last video on blocking probabilities. In the last video we talked about blocking probabilities and we talked about parallel links, and the blocking probability of a link made up of two parallel links was the product of the two blocking probabilities, or in general with n parallel links the blocking probability is the product of all blocking probabilities, and it's the product because every link needs to be blocked for the overall link from A to B to be blocked. Now we want to ask the question about the blocking probability from A to B where the link is made up of some number of series links. So P1, P2, all the way up to Pn. Okay, and in the case of two links we have P1 and P2 being the blocking probabilities of two individual series links making up the link from A to B. And this one's actually more complicated to think about than the parallel case. In the parallel case, what we did was we said there were many ways for the parallel connection to be open, that is, unblocked. And it can be open in any of the combinations of blocked or open parallel links, such that even if one path is open, then the path from the A to B is open. Okay? And so our guiding principle here was that there was only one way for the link from A to B to be blocked, and that was if all of the links are blocked. Okay? Here, it turns out there's only one way for the link to be open. It's just the opposite case. There's lots of ways for it to be blocked. It could be any combination of these things being blocked. But there's only one way for it to be open, and that's for every single link along the way to be open. Okay? And so you'll recall that P open for any given link is equal to 1 minus P block. Right? And what we're going to do is we're going to say that P block from A to B is equal to 1 minus P open from A to B. Okay? And now what's the probability that this link is open from A to B? Well, each link has to be open. Okay? And we're going to use that same guiding principle from probability theory, that we take the product of the probabilities of each of these things that have to happen. And so the probability that link number 1 is open is 1 minus P1, because P1 is the blocking probability. The probability that link 2 is open is 1 minus P2. Okay, and so this is the probability that the link from A to B is open. Therefore, the probability that the link from A to B is blocked is 1 minus this. Okay, 1 minus the product of 1 minus P1 and 1 minus P2. For n series links, we have that P block is 1 minus the product of 1 minus the P sub i's, for I equals 1 to n, where P sub I is the product, is the blocking probability of series link number I. Okay? And so this is how we calculate blocking probabilities for links in series. Okay? If all of, and so now what I'm going to do is I'm going to go ahead and summarize the equations for series and parallel links. So for parallel links, we have P block is the product of the P sub i's. I equals 1 to n. And this becomes P to the nth power in the case where all the P sub i's equal P. Okay? So it's a product of a bunch of probabilities. Well, if they're all the same, it's just that probability raised to the nth power. And for series links, P block is 1 minus the product of 1 minus the blocking probabilities. And again, in the case where all the PI's are equal, we can rewrite this and simplify it. It's 1 minus P to the nth power. Okay? Okay, in the next video what I'm going to do is I'm going to show you how to combine different combinations of series and parallel links to take care of more complicated cases, and in particular we're going to show you the topology of the three-stage switch designs.